Okay, so just a minute, I am coming to velocity. Okay, so everybody now, this is the velocity diagram. This is the velocity diagram for the impulse turbine. So this is, I think, again I will repeat now. Here, this is the tip of the blade, or it is a cross section of the blade, moving blade, and through this particular nozzle, the steam is coming impacting on the blade in the tangential direction. Then the resultant velocity coming from the nozzle at inlet is V1. So remember that here V is the symbol in this diagram you have used, but many of the books they have uh, given, or they have mentioned C as a symbol for the steam velocity. So here whatever the V is there is replaced by many cases in many books it is by C. Okay, so C is a velocity of steam and its related component. So V1 is the velocity of steam coming from this particular nozzle. Okay, so this V1 makes an angle alpha 1 with the tangential direction. Okay, so this V1 is having two components. Who will tell? This V1 is having two components. Now here it is Va1 is given, so it is in our diagram it is a Vf1 is there. Okay, and Vw1. Okay, so Va1 or Vf1, I am repeating, Va1 or Vf1. Okay, so Vf1 or Va1 is the vertical component of V1, which is responsible for making the flow of fluid or water throughout the turbine, or flow of steam throughout the turbine. Okay, then V1's horizontal component is there, it is called as Vw1. It is called as whirl component of steam at inlet. So again, I on that day I have cleared you that suffix 1 stands for inlet velocity triangle, or it is component 2 of the inlet velocity triangle. For example, V1, alpha 1, U1 or U2, but U1 and U2 both are same is equal to U. Okay, U1, then VW1, beta 1, VR1. So these represent the inlet velocity triangle, suffix 1. And similarly, when the steam leaves this particular blade at the outlet side, so whatever triangle is construct, or it is made, or get prepared at the outlet, it is called as outlet velocity triangle. Again, it is denoted by suffix 2, that is Vw2, V2. Okay, Va2 or Vf2. Okay, so this is going to be the air inlet velocity triangle and outlet velocity triangle. So nozzle, from the nozzle, the steam is coming with the velocity V1. Okay, it is having two components. हाँ सर, हाँ हाँ कहाँ से क्या समाधान चर्चा करेगी, समाधान दिले सर. Samadan. So V1 is the velocity of the jet or steam coming from the nozzle, alpha, making angle alpha 1. So this V1 having two components, one is VW1 and VF1. Okay, vertical is VF1 or VA1, and horizontal is VW1. Okay, at the same time, the blade is moving with the velocity U. Okay, and the difference, the here in between these two components v1 and u1 is equal to vr1, and it is called as relative velocity component. That is, actually it is a diagrammatically the velocity difference between v1 and u1. Vector diagram, vector, it is vector quantity, vector diagram we go for. So this is a v1 and u's difference is equal to vr1. Whatever the vr1 makes angle with the tangential direction, horizontal direction, is called as beta 1. It is called as blade angle at inlet. Okay, okay, now these are the only components, and afterwards at the tip of the outlet tip v2, there is velocity coming from that particular, if smooth gliding, it is the relative velocity component is coming. Okay, vr2, then v2. V2 is also having two components, one is vw2 horizontal component, vertical component of v2 is vf2 or va2. Okay, and whatever the v2 makes an angle with tangential direction, horizontal direction, it is called as alpha 2. It is called as nozzle angle at outlet. And vr2, whatever it makes angle with the horizontal, it is called as beta 2, that is blade angle at outlet. Okay, then the relative velocity difference, now this is a u, and the remaining component is there, it is going to be u. So this is going to be inlet velocity triangle green. Okay, and this is going to be outlet velocity triangle. Then that time here as, okay, the notations are there. Here we have one absolute velocity of steam. So already little bit difference. I mean our components we have made little. C is a velocity component, and VA1, instead of that VA1 we call it as a VF1, flow component of steam at inlet. Okay, and this is very much important. Is a combined velocity triangle diagram. A combined velocity triangle diagram. Okay, so this is U, that is a b is u. Okay, then this is ac, that is alpha. On that lecture I think I have drawn, I have told you how to draw. So this ac component is there equal to v1. Okay, it is coming, this is a common, that blade velocity is common in both triangle u, and this is u is equal to u1 is equal to u2 in case of this particular impulse turbine, and therefore u is common. Therefore we have taken advantages that this u is common for both diagram. Therefore we have taken combined velocity diagram, means u we have made as a combined. Okay, so v1, after that ab represent u. Okay, then ac is equal to v1. What now we have to draw the graphically this particular diagram. So whatever the magnitude of v1 is given, u is given, so we have to we have to decide some scale for that. Okay, so if u is 400 meter per second and v1 is 1200 meter per second, then if I will consider that scale is equal to 1 centimeter is equal to 100 meter per second, then u's will be equal to 4 centimeter, and v1 is equal to 1200 meter per second means 12 centimeter. So this ac we have to draw. Okay, angle of nozzle is given alpha, this is alpha 1. Okay, then u we can draw, and afterwards relative difference between u and v1 is nothing but what, vr1. We will get in that case ac will get by v1 plotting v1, ab will get by plotting u. Okay, then b and c if you join, that we call it as vr1. Whatever the vr1 makes angle with the horizontal, it is called as beta 1. Alpha 1 we are knowing nozzle angle at inlet, initially it is given in the numerical. Okay, then here we know that v1 is having two component. One is horizontal component is vw1. Okay, and vertical component is vf1 or va1. Ec represent the vertical component va1 or here vf1. Okay, so this way we have completed the diagram, inlet velocity triangle. Similarly, from vr1 only the emerging another component will emerge, that is called as vr2. Okay, it is called as relative velocity component of steam at outlet VR2, it makes an angle beta 2 with the horizontal. Okay. If we join this VU and VR2, difference in the remote what? V2. This V2. And V2 is having another two component. One is vertical is called as VF2 and horizontal is called as VW2. So in this diagram, U is common. Okay. Now everybody understand this diagram? Now this diagram actually we have to draw graphically, but I think nowadays last year onwards, so from the syllabus, these numericals on steam turbine they have not mentioned. Actually there is numerical treatment, numericals are there on this particular steam turbine, but I think nowadays in the revised syllabus they have cancelled the numericals on the steam turbine. We'll see afterwards. Now as this examination we got the information that will be online, therefore such triangles only, notations etc we should know, or we should draw this. I think last lecture I have given you, means we have taken one diagram. Okay, and I asked you to draw the diagram. Have you drawn last lecture? Have you completed this work? Anybody of you can tell me? Last lecture I think those were present. Yes, sir. Shubham Singh. Good, good. Shubham is remembering. Good. Then last lecture, only Shubham is replying. Others or other somebody can speak. Unmute. Okay, so this is a okay. Kunal Shetty is yes. Okay, yes. Janeshwar, yes. Nikita Power, yes. Okay. Then okay. Okay, now I think on screen we are having the different how to calculate the different performance parameters of a steam turbine. Everybody is now visible, getting the screen, work output, power, blade efficiency, and stage efficiency. Okay. Now the force in tangential direction. Now when the steam is impacted on that particular blade, what will happen? It will exchange its momentum to the moving blade, and the momentum of steam is goes on decreasing. So if anything's movement is goes on decreasing, what will be produced? Anybody? If steam is impacting on that blade, blades are moving with lesser velocity than the steam, or sometimes maybe they are stationary. Now when steam is strikes or impact on that particular blade here, then momentum of steam, momentum is nothing but what? Mass into velocity of that steam goes on decreasing, because it will give movement to blade, and blade will move with different movement, but steam will lose its moment. Okay, then momentum change will occur there. If momentum change will occur, what will be produced? Anybody? According to Newton's second law of motion, anybody? Somebody can speak. If momentum is changing, maybe of that blade or that steam, what will happen? A steam momentum. But if the steam is losing its momentum gained by the blade, and in that process, what will develop? Anybody? Okay. So what is Newton's second law of motion? Anybody? So force is developed. So according to rate of change of momentum is nothing but what? Force developed. So which component is in the tangential component is Vw1 and Vw2. Okay. Therefore, force in the tangential direction is equal to rate of change of momentum in tangential direction. So tangential direction means the steam is losing its momentum and force is going to be developed. Therefore, mass per second, rate of change of momentum is nothing but mass into velocity change. Mass per second into change in velocity in newtons. Okay, change in velocity and total is having unit newtons. So mass is m of the steam flowing, mass flowing per second. M we can denote by m or ms, and which are the responsible component the tangential direction is nothing but Vw1 minus Vw2 plus minus Vw2. Okay. Then in this case, if both components are coming in negative direction, means in that case, if you see the diagram, okay. So here, if you see that Vw1 is going in the direction of V1, that is towards left side, and Vw2 towards the right side. So in this diagram, Vw1 and Vw2 they are in the opposite direction. So in this case, okay. So in this case, Vw1 and Vw2, if they are in negative direction, Vw1 will be positive and Vw2 will be negative. And negative of that minus minus will become minus of minus Vw2. It will become positive. And in that case, if m into Vw1 plus Vw2, but to have the plus sign here, what is the requirement is there that Vw1 and Vw2 should be in opposite direction. If they are in the same direction, then m into bracket Vw1 minus Vw2. That is in newtons. That is a force in the tangential direction. And this force is responsible for getting the work done by the turbine or power from that particular turbine. Okay. Then force in axial direction. Axial means vertical direction, axial thrust, and that component is Va1 minus Va2, m into bracket. Both components in this case are here in the same direction, that is downward direction. Therefore, Va1 minus Va2. But here it is if Vw2 and Vw1 are in same direction, then it will become m into bracket Vw1 minus Vw2. If they are in opposite direction, it will become Vw1 plus Vw2. Axial component m into bracket Va1 minus Va2 or Vf1 minus Vf2. Okay. Then work done by steam on blades is equal to what? W. If we know first force, then how to calculate W? W is equal to F into S. F force into X displacement. So yes, therefore work done by steam on blades is equal to M into bracket Vw1 plus minus Vw2 into U. U is equal to velocity, means displacement per unit time, it is equal to U. So M into bracket Vw1 plus minus means now again this sign plus when Vw1 and Vw2 are in same direction, here minus sign. Vw and Vw2 are in opposite direction, plus sign into U. So this represent the here M into bracket Vw1 plus minus Vw2 into bracket U is nothing but Newton meter per second. Okay, and it is called as anybody Newton meter per second. W is equal to F into S. Newton meter per second is called as anybody. At what happened today? Nobody is answering. After Diwali, this is I think first lecture, na? What happened? So this Newton meter per second is called as anybody. Next stage, I think I have given that answer. Newton meter per second is called as, somebody can message everybody, so that I will get that you are in lecture. Newton meter per second is called as watt. Correct. Now Swas is going to answer after a long time. Good, good. And this is called as power also. Okay. So VW1 minus here M into bracket VW1 plus minus VW2. It is called as U Newton meter per second, or it is watt. Or power developed, if you want, that is also called as power developed. Work is equal to called as power developed watt, and power developed by turbine is equal to same M into bracket VW1 plus minus VW2 into bracket U, where U is blade velocity, VW is whirl component of steam at inlet, VW2 whirl component of steam at outlet, and divided by 1000. It is in kilowatt. Okay, so this is the power developed by turbine. This is also watt. Work or power are same. Okay, then blade efficiency. How we can define the blade efficiency? The blade efficiency defined as, it is the ratio of work developed by the blade or turbine. Blade means it is called a turbine. Okay, work developed by the blade divided by energy supplied to the blade. And which is the energy supplied to the blade? It is nothing but kinetic energy. So work done on the blade is equal to, already we have calculated, M into bracket VW1 plus minus VW2 into bracket U divided by energy supplied is 1 half mv1 square, and is equal to, if you can here resubstitute is mm will get cancelled. Okay, and 2 into 2 will get to the numerator side, 2 into bracket 2u, this u we are taking this side, 2u vw1 plus minus vw2 into bracket u divided by v1 square. Okay, and then it is called as 2u vw1. This is with the help of this formula one can calculate the blade efficiency. Okay, then energy loss due to blade friction. Okay, energy loss due to blade friction is nothing but what, VR1 1 half m into bracket VR1 square minus VR2 square. Okay, then stage efficiency. Okay, so we know that if the enthalpy of that steam is decreasing, definitely we are getting the work. So stage efficiency, the turbines consisting of several stages. Okay, so stage efficiency is considered as, now we are getting what we are getting, the total enthalpy drop generally we are getting. Okay, then in that case the total stage efficiency is called calculated as work done on the blade divided by total energy supplied per stage. Total energy supplied per stage, or it is calculated by formula F m into bracket h1 minus h2, or it is called the enthalpy drop, h1 minus h2. Okay, and mm will get cancelled. So in that case, it is equal to vw1 plus minus vw2 into u divided by hd, or where hd is called as what, total enthalpy drop. It drop in the nozzle. Okay. So next is there maximum work and maximum diagram efficiency. What will be the diagram, maximum diagram efficiency of that particular turbine blade? Okay, so work output, power, blade efficiency, and stage efficiency. Now we want to calculate. Just a minute. Okay. On your screen, I think which slide is now visible? Maximum work and maximum diagram efficiency. That slide is visible.
Yes, sir.
Okay.
Yes, sir.
Okay. Sir. Thank you. Thank you. Okay. Now we know that the maximum blade efficiency of impulse turbine or efficiency of the impulse turbine is given by a formula. It is 2u into bracket VW1 minus VW1 plus minus VW2. Okay, divided by u1 square. Sorry, divided by v1 square. With the help of that formula, one can calculate the efficiency of blade. Now, whatever the combined velocity diagram is there with us, so let us will go to. Okay. So from the combined velocity diagonal diagram, okay, let us now, if diagram is there with you, then you can put that diagram in front of you. VW1 is equal to V1 cos alpha 1. So if your diagram is there with you, then you can try that triangle you can draw, and here that triangle here VW1 is equal to, in that case, AC. Okay, and is that equal to one right angle triangle is there, ACE. Okay, and in that case, if you write that VW1 is equal to V1 cos alpha 1, so cos alpha 1 is equal to, in that case, here VW1 divided by here C1. Okay, and therefore VW1 is equal to V1 cos alpha 1. But if you arrange that V1 cos alpha 1, that is, in that case, is nothing but what, VW1. If you can write it as a AB, that is U, tangential velocity U plus BC. And if you construct one triangle, that left hand side that triangle, then in triangle B BCE if cos beta 1 is equal to CB divided by CR1, okay, or VR1, okay, and in that case what this it will become V1 cos alpha 1 is equal to, it will become V1 VR1 cos beta 1 plus U, and similarly in that case VW2 will become V2 cos alpha 2 and is equal to VR2 cos beta 2 minus U. In our diagram it will become what it has become, VW1 and VW2 they are going in the opposite direction, okay, therefore VW1 is equal to VR1 cos beta 1 plus U and VW2 is equal to V2 cos alpha 2 is equal to VR2 cos beta 2 minus U. So this trigonometry we have to use. If you add this VW1 and VW2, okay, and otherwise let us okay, if you are not understanding with diagram is required, let us see, we'll try to at least the VW1 these steps, okay, just for that I will stop going in the diagram. So entire screen I will present for some time so that it is not possible here from. Just a minute. Okay. Okay, thank you. Okay, so here is our diagram. Now this is, I will draw this with now A, this will be B, okay, and this is equal to U. So from this, here when come well, it is a steam velocity coming from the nozzle. Okay, so it is making an angle. This component we call it as now V1. In some diagram it is called as C1. It is making angle alpha 1 with the tangential direction or horizontal direction. Okay, then relative difference between U and V1, that we called as a VR1. Okay, now remember that this U V1 is in this direction, that is left right, what you can call right to left direction, negative direction, and here this is V1's horizontal component. V1 is having two component. One is inlet component, and sorry, one is horizontal component or tangential direction component, and one is vertical direction component. So it is equal to VW1. So horizontal component of V1 is called as VW1, and vertical component, okay, or it is called as VA1 in our this diagram, in our derivation, VA1 or VF1. Okay, flow component of steam at inlet. And this is now right angle triangle we can consider. So this is a B. If you consider this as a C, let us consider this as a E. Okay, then we are considering it as a what, tangential force. Now here this is alpha, whatever the VR1 makes an angle with the horizontal, that we called as a beta 1 angle. This is a blade angle at inlet. So this is our inlet velocity triangle. Similarly, what we are doing, this is VR2, this is a U is a blade velocity is common. So from this here Another component is coming as what? VR2. This makes an angle beta 2 with the horizontal. Okay, and this u and vr2, the difference, as there is a difference in between u and v1 as vr1, that is similarly here vr2 and u, that difference we called as now related difference is v2. Now similarly here v2 is also what, having two components again, as it is the resultant velocity of steam, so it is having two components. What is there? One is we call it as a perpendicular direction, so it is a vf2, and whatever direction is there of v2, same direction another component is there, it is called as vw2. vw2. Okay, so this vw2 is going in opposite direction. Now if you see here, vw2 is in positive x direction from left to right, and v1 is in here v1 is in here right to left direction. Like way vw1 is also in the same direction of v1, and vw2 is the same direction of v2. Okay, similarly in that case here now we want to have the derivation for this. So we know that now here total resultant component vw1 and vw2, it is called as vw, it is called as resultant whirl component. Okay, now here if we do this here calculation now, so here in this triangle, this is a one triangle aec, if you consider, then vw1, I want to write the equation for vw1. Okay, then what is vw1? Here vw1 is equal to that, whatever the diagram is there, vw1 is equal to what you can say here, it is in terms of this v1 and alpha 1, it is equal to what? v1, it is right angle triangle abc. Okay, what is that? Cos alpha 1 is equal to, so I want to write, so therefore cos alpha 1 is equal to what you can say, it is equal to vw1 divided by which triangle? This triangle aec triangle. Cos alpha 1 is equal to here vw1 divided by here v1, and therefore vw1 is equal to what? v1 cos alpha 1. v1 cos alpha 1. This also I can write as a, this is a v1 cos alpha 1. Now I will write it as what? v1 cos alpha 1 is equal to what? u, this is a ab, this is equal to ab, or I can write it as in terms of nomenclature ab plus bc. But what is ab? ab is equal to, anybody? ab is equal to u, velocity, tangential blade velocity component, plus what is bc here? bc is equal to this bc we have tried, or right bc. Okay, now this bc is equal to, what is that? In this triangle cbec, what is this bec? Cos beta 2 triangle, I will write the triangle bec, right triangle bec, consider that is a right angle triangle bce. Okay, for bec, what happened? Cos beta 2, cos beta 2, sorry, cos beta 1, cos beta 1 is equal to, what is cos beta 1 is equal to? Anybody? BC divided by BC divided by VR1, and therefore this implies that BC is equal to this BC is equal to VR1 cos of beta 1. VR1 cos of beta 1. Okay. Therefore, if we put this, VW1 is equal to what? U plus VR1 cos beta 1. And in this case, what is that? Here, this VW2 is very less, and VW2 is equal to, if you solve this, VW2 is equal to what? Here, VR2 cos of beta 2 minus U, because VR2 cos beta 2 is this much. This is what? This will be equal to VW2 in that case is equal to this VR2 cos of beta 2 minus U. So this we have to understand. Okay. So with this now we'll go to okay. Now here VW1 we got it as a V1 cos alpha. Understood? Please EPS it you can write yes. Message or anybody is concentrating or not, and understood. If it is not there, I will yes sir. Nikita Pawar, good. Dineshwar Misal, good. Others keep live. This is very difficult for us to teach this derivatives kind of subjects. Okay. So VW1 is equal to V1 cos alpha 1. Similarly, I have given that VR1 cos beta 1 plus U. Okay. And VW2 is what? VR2 cos beta 2 minus U. Now here we know that blade efficiency is equal to what? 2 into U, 2U into bracket VW1 plus VW2, okay, divided by V1 square. Now, therefore, V1 plus VW2 now, this VW1 is equal to VR1 cos of beta 1 plus U, okay, plus VR2 cos beta 2 minus U. And in that case, here this plus U and minus U will get cancelled, and VW1 plus VW2, it will become VR1 cos beta 1 plus VR2 cos beta 2. If you take this common, VR1 cos beta 1 in that case is equal to 1 plus VR2 cos beta 2 divided by VR1 cos beta 1. Now we are defining this term. Now VR2 upon VR1, it is called as here K, or it is called as blade coefficient. It is called what? Friction coefficient or blade coefficient. It is called as friction coefficient and here or blade coefficient, friction coefficient. So VR2 K is equal to VR2 upon VR1, and cos beta 2 upon cos beta 1 is called as constant C. And it depends on the blade angle, that is beta 2 and beta 1. Okay, so we are defined. Therefore, it will become now VW1 plus VW2, it will become VR1 cos of beta 1, VR1 cos of beta 1 into bracket 1 plus Kc. Okay, but here VR1 cos of beta 1. What is VR1 cos of beta 1? Here I will go here. VR1 cos of beta 1. VR1 cos of beta 1 means what? BC. And is equal to what? VW1 minus U. VW1 minus U. And therefore, and VW1 is equal to V1 cos alpha 1. So V1 cos alpha 1 minus U. Okay. So this will become VR1 cos of beta 1 is equal to what? Here it will be V1 here VR1 cos of beta 1 is nothing but is BC and is equal to what? Here V1 cos of alpha 1 हे सगळा बी ए सी मायनस यू. ओके, V1 cos of alpha 1 minus U into bracket keep 1 plus KC. अंडरस्टूड. आता VW1 आणि VW2 मधले आपल्या डायग्रामचे एफिशियन्सी फॉर्म्युले आहेत. तर आपण त्याला काय केलं, VW1 प्लस VW2 वी आर गेटिंग V1 cos alpha 1 मायनस U into bracket 1 plus KC. के म्हणजे काय आहे, VR2 upon VR1 रिलेटिव्ह व्हेलॉसिटी कोएफिशियंटला म्हणायचं, अँड सी फ्रिक्शन कोएफिशियंट, आणि सी म्हणजे ब्लेड कॉन्स्टंट, अँड इज इक्वल टू cos beta 2 divided by cos beta 1. अंडरस्टूड. प्लीज राईट यस. इथपर्यंत सगळं समजलं, अजून रिपिटेशन काय पाहिजे? ओके ओके. देअरफॉर nobody is giving answer. Okay, Nikita Power is only understanding, others okay. Ganeshwar is understanding, good. Kunal etc. Kunal, Suhas, Gaikwad. Rate of doing work per unit. Therefore, now we are knowing the formula. Rate of doing means nothing but what? It is VW1 plus VW2 into U. Therefore, but we know that VW1 plus VW2 is equal to V1 cos alpha 1 minus U into bracket 1 plus KC. And this is equal to what? Into U. Only U we have multiplied. Then diagram efficiency is equal to what? 2 into bracket. 2 into bracket here. Here 2 is missing. Sorry. Here it is, there mistake is there. 2 is missing. V1 cos alpha 1 minus U into bracket 1 plus KC. That is actually 2 into U, 2 into U, CW, VW1 plus VW2 divided by V1 square. So here, here it is U is missing here. Actually, I have made mistake. So then let U rho is equal to U upon V1. Blade speed ratio is called what? Blade speed ratio. Okay. Therefore, diagram efficiency. आता ह्याच्यामध्ये काय झालं, एक मिनिट, I will write. So okay. So blade EP. Now we want to calculate eta blade. Is equal to, what is that formula we got? Is 2U VW in, sorry, 2U in bracket VW1 plus, okay, VW2, because both are in opposite direction, therefore plus sign. 2U into VW1 plus VW2 divided by V1 square. Okay, but we know that VW1 plus VW2, what is that VW1 plus VW2? Anybody? VW2 plus VW2, it is equal to here V1 cos alpha 1 minus U plus into bracket 1 plus KC. Okay, so is equal to two into bracket V1 cos alpha 1, okay, minus U into bracket U divided by V1 square. Okay, now here what we are doing is, and sorry, into bracket now 1 plus KC, 1 plus KC. Okay, now here what we are doing, here U upon V1, let what we are doing, 1 into speed ratio, blade to, it is a speed ratio, that is blade velocity to steam velocity ratio, it is rho, that we are defined as one constant, that is rho, it is equal to U upon V1. That U upon V1 is equal to what? Rho. So in that case, this u and this one v1, it will become rho, and therefore it will become what? Eta blade is equal to what? This two, this u upon v1, I will call it as what? Rho. Okay, 2 into bracket 2 into rho into bracket v1 cos alpha 1 एक यू आपण आणि व्ही वन याचा रेशो काय घेतला आपण रो घेतला व्ही वन कॉस अल्फा वन मायनस यू इंटू ब्रॅकेट काय येणार वन प्लस के सी डिवायडेड बाय काय आहे एक आपला ऑलरेडी एक व्ही वन आहे ओके getting now what we'll do this v1 will take common this v1 will take common and therefore it will become what जे जर v1 common काढला तर काय 2 रो into bracket v1 common काढला आपण वर v1 into bracket काय v1 cos alpha 1 v1 काढल्यामुळे इथे काय झालं फक्त cos alpha 1 हे जर तुम्ही लिहित असेल तर लिहून काढा बरं का काय काय गोष्टी v1 आणि हा u upon v1 आपण u upon v1 काय आहे चला राइट और एक एक स्टेप वर्ड हो रहा u upon v1 into bracket 1 plus k into c आता हे divided by v1 and this v1 and this v1 will get cancelled and this will be called as rho therefore eta blade in that case is coming as what 2 rho what is rho it is a blade here speed ratio or it is a ratio of what blade velocity to inlet steam velocity 2 rho into bracket cos alpha 1 minus rho into bracket 1 plus AC. Okay, now this is our derivation. Now I'll here eta blade is coming as what? Here 2 rho cos alpha 1 minus rho square into bracket 1 plus Kc. Just a minute. Okay, this way there this row they have taken inside there it will become 2 into bracket okay so this row also they have taken inside okay now later we'll go okay 2 into rho cos alpha 1 minus rho square plus 1 plus Kc okay now here from the above equation the diagram efficiency is depends on whatever the efficiency is there of blade depends on the nozzle angle at which angle that nozzle is located then blade to speed ratio blade speed ratio okay it is called as rho the u upon v1 blade angles beta 1 and beta 2 and blade velocity coefficient k okay and k is equal to in that case here cr2 upon cr1 or friction coefficient if the values of alpha 1 k and c are assumed to be constant the diagram efficiency depends only on the value of blade speed ratio. So these are the blade coefficient. These are values of blade. So only variable quantity is rho u upon v1. Therefore, in order to determine the optimum value of maximum efficiency, that I told you that condition that is maximization or minimization condition. Okay, what is that? This efficiency formula depends on which variable that is rho. Then that efficiency formula should be differentiated with that variable quantity that is d rho and that differentiation where to equal to 0. Okay, now here in this case, okay, I will solve. So okay, so eta blade is equal to what we are getting? Eta blade is equal to here 2 into bracket 2 into bracket rho cos alpha 1 minus rho square into bracket 1 plus k into c. Okay, no, okay, so this is the blade velocity. Now if you see that what happens, this rho, this blade efficiency depends on this alpha 1 angle, then rho, okay, then k and c. It is k, c and this blade angle, they are constant related to blade parameter. It depends on the manufacturing. So therefore only this blade efficiency depends on rho. Okay, so therefore eta blade varies with what we can say, eta blade varies with rho is equal to u upon c1. Okay, and that is therefore now to get the maximum efficiency condition, what way to do is there. So this eta blade, d eta blade, this equation we have to differentiate with respect to variable quantity which depends on d rho, and that differentiation we have to equal to 0. Okay, so this is the condition for maximization or minimization. This is the optimization technique. Okay, so therefore d eta blade divided by d rho, this equation we have to differentiate with respect to rho, and we have to equate that total differentiation equal to 0, and in that case other parameter will act as a constant. Okay, therefore 2 as it is. Okay, so differentiation of rho cos alpha 1, it will become only rho's differentiation is cos alpha 1 only. Cos alpha 1 will become constant, cos alpha 1, okay, minus this 2 rho, this will become what 2 rho into bracket 1 plus kc. Okay, and okay, this we have to equate it to 0. Okay, therefore if you equate this k1 plus kc2, it will get cancelled. Therefore cos alpha 1 is equal to 2 rho, and therefore rho opt म्हणजे this is called as optimum value of rho काय असावी, rho opt is equal to cos alpha 1 divided by 2. So this is the optimum blade speed ratio is should be equal to cos alpha 1 divided by 2, and this they can ask in the examination in the MCQ. Rho optimum. So for maximum efficiency, what should be the blade and speed ratio? Rho opt should be equal to cos alpha 1 divided by 2. How we define? We have calculated blade efficiency. Okay, and this blade efficiency varies with respect to rho or u upon c1. Therefore this blade efficiency we have differentiated with respect to d rho, which is variable quantity, and we have to equate it to 0. Then afterwards, after doing that, we here got that 2 cos alpha 1 rho is cos alpha 1 will be constant into differentiation of rho is 1. minus 2 rho is into 1 plus kc is equal to 0. And as is equal to 0, 2 this 1 plus kc will get cancelled, and in that case cos alpha 1 will become 2 into rho. Therefore rho of term is equal to cos alpha 1 divided by 2. Everybody got it? Got it or not? I want your feedback. I am trying to cover. I am trying that everybody will understand. uh, if you are concentrating, you will understand. So please write your message so that anybody want to repeat that also you can write. If you want to repeat, you can unmute yourself and you can tell. uh, Write the message so that I can continue next. So in case of the impulse steam turbine, the value of optimum value of blade to speed ratio is equal to rho is given by cos alpha 1 divided by 2. Please write message. Otherwise, I understand that you are not understanding. Nobody is understanding. Kunal, repeat. Shaneshwar, what to be repeat? Shaneshwar, unmute and tell so that everybody will understand. Shaneshwar,
Yes, sir. The
what?
previous slide.
Uh, uh,
Previous slide.
Previous slide.
Hmm.
This
Yes,
or
sir.
what? This one. Shaneshwar,
Yes, sir. Yes, sir.
this only. Okay. Okay. So blade efficiency, we got that. Okay. So we'll. So instead of that, I will write again now. No problem. So okay. So blade efficiency. Now I'll go cover fast a little bit. Okay. Blade efficiency. We got the formula. That is work done divided by inlet velocity divided by inlet kinetic energy, or it is inlet kinetic energy. So is equal to work done. We know that the formula is what? Here in the tangential direction, here it is equal to given by equation VW1 plus, if both are in opposite direction then plus sign, because minus minus will become plus, VW1 plus VW2 into bracket U. Actually, so tangential force is equal to VW1 plus VW2. Okay. And rate of change of momentum. Okay. F in VW1 into VW1 plus VW2, and work done is equal to VW1 plus VW2 into U. This is into divided by kinetic energy. What is kinetic energy at inlet? The steam is coming with velocity v1 from the jet. Therefore, its kinetic energy will be equal to 1 half m v1 square. Sorry, it should be multiplied by mass also. That okay, mass into acceleration, m into a, and this m and this m will get cancelled, and therefore blade efficiency formula will become what? This 2 into u, u itla घेतला मी. Okay, and in bracket vw1 plus, and both are in opposite direction. VW1 कुठून जातोय? राईट कडून लेफ्ट कडे जातोय, आणि VW2 लेफ्ट कडून राईट कडे येतोय. म्हणजे बोथ आर इन अपोजिट डायरेक्शन. डिवाइड बाय एम विल गेट कॅन्सल, आणि दोन इकडे गेलं, खाली राहिला V1 स्क्वेअर. दिस फॉर्म्युला एव्हरीबडी अंडरस्टँड. आता दिस इज अ फॉर्म्युला फॉर ब्लेड एफिशियन्सी. Shaneshwar,
Yes, sir.
okay, now you can others, they can write message. Okay, then this VW1 and VW2, we got that equation from this formula we got from velocity diagram. Okay, from velocity diagram. So previous slide, what we got? VW1 and VW2. VW1 I have told explained. It is V1 cos alpha 1 plus is equal to AB plus BC, and VW2 is VR2 cos beta 2, and therefore VW1 plus VW2. Next slide. VW1 plus VW2, we are getting it as a U will get cancelled. VR1 cos of beta 1 plus VR2 cos beta 2, and VR1 cos beta 1 we have taken common. In that case, it will become 1 plus here VW1 plus VW2, VR1 cos of beta 1, okay, into bracket, another bracket, 1 plus VR k into C, okay, and VR1 cos of beta 1 we have written as a V1 cos alpha 1 minus U, okay. तर हे आपण थोडं आता हे काय केलं आपण, नाऊ वी आर रायटिंग, okay, so therefore this is equal to, okay, or otherwise VW1 plus VW2 is equal to 2 into bracket U, आणि ह्याला आपण काय म्हणले मग तुम्हाला एक्सप्लेन केले मी, इट इज V1 cos alpha 1 minus U into bracket काय 1 plus KB, हे आपण एक्सप्लेन केलेलं, हे अंडरस्टँड केले सिनेश्वर, हे माहिती आहे ना तुम्हाला, फॉर्म्युला मग आपण डिराईव्ह हे केले, डायग्राम वरून काढलेलं आहे. VW1 plus VW2 is equal to what? V1 cos alpha 1 minus U into bracket 1 plus KB divided by here V1 square. Okay, now what we have done now afterwards, this V1, what we have done, we have defined one constant, that is blade to speed ratio, blade to blade velocity to steam velocity, blade velocity ratio rho, and is equal to, we have defined it as, we did definition of course, U upon V1, blade to steam velocity at inlet, that is called as rho, it is called as U upon V1, okay, and therefore here this blade efficiency will become, now what will become, 2 into this U, ह्यातला U आणि V1 मधला हा U आणि एक ह्यातला हा V1, म्हणजे ऑलरेडी तो काय झाला, रो झाला, बरोबर आहे, 2 रो, याला वाटलं मी तिथं इथंच याला ह्यातला राहिलेला V1 इथे टाकतो तुम्हाला समजेल, ओके, इनटू ब्रॅकेट, आता ब्रॅकेट मध्ये काय राहिला फक्त V1 cos alpha 1 minus U आणि डिवायडेड बाय, सॉरी, इनटू 1 प्लस KB. ओके, आता V1 हा 2 रो आपण ह्यातला मी आता U काय करतो, हिचं कॉमन काढतो, ओके, सॉरी, ह्या V1 मी कॉमन काढतो, इथला ब्रॅकेट मधला V1 आहे तो मी काय करतो, कॉमन काढतो, तर काय राहील आपलं, तर ब्लेड इटा ब्लेड इज इक्वल टू, ब्लेड इज इक्वल टू काय 2 रो डिवाइड बाय V1, ह्या ब्रॅकेट मधला V1 मी कॉमन, आय विल टेक कॉमन, व्हॉट इज रिमेन इन ब्रॅकेट नाऊ, V1 काढला तर cos alpha 1 मायनस U अपॉन V1, cos cos alpha 1 मायनस U अपॉन V1, ते V1 कॉमन काढल्यामुळे, ओके, आणि इथं काय राहिलं ब्रॅकेटमध्ये 1 प्लस KB, ओके, आता ह्याला U अपॉन V1 ला आपण काय म्हणतोय, हा V1 आणि विल गेट कॅन्सल, ह्याला आपण काय म्हणतोय, रो, देअरफॉर इटा ब्लेड इज इक्वल टू, eta blade is equal to, what will become now, 2 रो cos alpha 1 minus rho in another bracket 1 plus a into b. ओके. आता हा रो आपण आतमध्ये घेऊन मल्टिप्लाय केला तर काय होईल 2 into ब्रॅकेट रो cos alpha 1 minus rho square into bracket 1 plus kb. Okay. Now this is efficiency formula. Are you getting up till now? Finish or no? Finish or?
Yes, sir.
Okay. Anybody?
Understood.
Okay. Now message. Everybody write message now. Okay. So as no problem. Now here we want maximum blade efficiency. For that, this blade efficiency depends on what? Rho, alpha 1, K and B. Okay. Out of that, here KB and this cos alpha 1 remain constant. Manufacturing property. Only variable property is what? Rho. Therefore, eta blade varies with rho. Therefore, to get the condition for optimization or maximization, what we have to do is there, this blade efficiency equation, we have to differentiate with respect to which quantity? Variable quantity, that is d rho, and this equation, this derivative completely we have to equal to 0. And therefore, what we will do now? Eta blade is equal to, therefore 2 is equal to constant now. Okay. Rho, differentiation of rho is equal to 1. Okay. And cos alpha 1 into cos alpha 1, it become cos alpha 1. Okay. Minus 2 rows काय रो 2 रो स्क्वेअर चे डिफरेन्शिएशन 2 रो. ओके. 1 plus k b is equal to 0. आणि हे जर 2 1 plus kb is equal to 0 असल्यामुळे कॅन्सल होणार. आपल्याला काय मिळणार cos alpha 1 is equal to 2 रो. आणि रोची काय व्हॅल्यू असली पाहिजे त्याला आपण रो ऑप्टिमम म्हणतो, कारण हे आपली किंवा रो मॅक्झिमम इफिशियन्सीसाठी रोची व्हॅल्यू काय असावी cos alpha 1 divided by 2. Understood? This is the optimum value of rho. Write in message box. Optimum value of rho in impulse turbine, what is that? Rho is equal to cos alpha 1 divided by 2. Others, Shaneshwar? Okay. So for impulse steam turbine, the optimum value of rho is equal to cos alpha 1 divided by 2. Okay. Now we want maximum efficiency. काय करायला maximum efficiency काढण्यासाठी आता? Anybody? काय करायला आपल्याला maximum efficiency काढण्यासाठी? maximum efficiency काढण्यासाठी काय करावं लागेल? Anybody? ही रोची जी व्हॅल्यू आलेली आहे ती या ब्लेडची इक्वेशन मध्ये ठेवायची आपल्याला. ओके. तर इफ यू पुट इट हियर, तर काय होईल आपलं इक्वेशन? आता मॅक्झिमम ब्लेड इफिशियन्सीसाठी मला काय करावं लागेल आता? इटा मॅक्स ब्लेड. तर मग जी ब्लेडचं इक्वेशन होतं आपलं, रोची व्हॅल्यू आपल्याला काय करायची फक्त कॉस अल्फा 1 त्या ह्याच्यामध्ये 2 into रो कॉस अल्फा 1 ह्याच्यामध्ये. मी वाटलं लिहून काढतो इक्वेशन. 2 into रो कॉस अल्फा 1 minus रो स्क्वेअर into bracket 1 plus AB. ओके. याच्यामध्ये रोची व्हॅल्यू काय ठेवायची आपल्याला? एनीबडी? काय आहे ती व्हॅल्यू सांगा एखाद्याने असं.
cos alpha 1 by 2.
cos alpha 1 by 2. गुड. ओके. ही जर पुटअप केली तर काय येईल आपली? आता रो ब्रॅकेट मारतो ओके, 2 into bracket cos alpha 1 divided by 2 into cos alpha 1 okay into cos alpha 1 minus काय येणार रोच व्हॅल्यू cos square alpha 1 divided by 4 okay, into bracket 1 plus kb okay, that you simplify it.
सर 1 प्लस केसी आहे ना केबी काय आहे?
सॉरी के सी घेतले का आपण सॉरी सी या कॉन्स्टंटला काय पुस्तकामध्ये बी म्हणलंय काय मध्ये सी म्हणलंय के सी म्हणलं चालतंय काय प्रॉब्लेम नाही हा नो प्रॉब्लेम इट इज कॉन्स्टंट के बी किंवा के सी सी जरी म्हणलं चालतंय तो काय सी आर के आर टू काय व्ही आर टू अपॉन व्ही आर वन व्ही आर टू कॉस बीटा टू सॉरी कॉस बीटा टू डिवाइड बाय कॉस बीटा वन हा बीचा ह्याला बी म्हणले काय पुस्तकामध्ये सी म्हणले तो काय आहे कॉन्स्टंटच आहे हॅलो काय ठिकाणी तो सी म्हणला याला हा म्हणजे ह्याला कॉन्स्टंट आहे आपला कुठला हा मग अशा आपण केलेला सी ह्याला आपण म्हणतोय कुठं गेला हा कॉन्स्टंट ह्याला आपण सी म्हणू शकतो ना बी हा कॉन्स्टंट आहे काय प्रॉब्लेम नाही काय पुस्तकामध्ये बी आहे काय पुस्तकामध्ये सी आहे ओके तर आता आपण बी आणले बी म्हणले तर बीच म्हणूया का ठीक आहे तर इज इक्वल टू आता हा सिम्प्लिफिकेशन काय येतो हा तर कॉस 2 इंटू ब्रॅकेट कॉस स्क्वेअर अल्फा 1 डिवाइड बाय 2 मायनस कॉस स्क्वेअर अल्फा 1 डिवाइड बाय 4 ह्याला 1 प्लस के सी म्हणा किंवा के बी म्हणा दिस इज ह्याला काय जास्त सध्या आपण बी म्हणले तर बी म्हणूया किंवा काय पुस्तकामध्ये के सी म्हणलेलं आहे तर 2 इंटू हे सिम्प्लिफिकेशन काय येणार आता 4 cos स्क्वेअर अल्फा 1 मायनस 2 cos स्क्वेअर अल्फा 1 डिवाइड बाय 2 म्हणजे इज इक्वल टू व्हॉट एनीबडी 2 इंटू ब्रॅकेट काय येणार आहे सिम्प्लिफिकेशन cos स्क्वेअर अल्फा 1 कोण सांगते 4 cos 2 cos स्क्वेअर अल्फा 1 डिवाइड बाय 2 इंटू ब्रॅकेट 1 प्लस ए बी करेक्ट सॉरी 2 cos स्क्वेअर याला काय दोन फक्त 2 cos स्क्वेअर अल्फा 1 cos स्क्वेअर अल्फा 1 डिवाइड बाय 4 एम राइट ना cos स्क्वेअर अल्फा 1 डिवाइड बाय 4 हे जर पहिले 4 cos स्क्वेअर अल्फा 1 मायनस 2 cos डिवाइड बाय 8 हा म्हणजे किंवा 2 cos स्क्वेअर अल्फा 1 डिवाइड बाय 4 यातनं जर 2 मूल्य केलं तर काय म्हणतात आपलं काय म्हणतात इक्वेशन ब्लेड इटा मॅक्स ब्लेड cos स्क्वेअर अल्फा 1 डिवाइड बाय 2 इंटू ब्रॅकेट 1 प्लस के बी किंवा के सी हा तर हा के ची व्हॅल्यू किती आहे CR2 जर ब्लेडचं फ्रिक्शन काहीच नसेल तर CR2 आणि CR1 हा एक असतो सेम असतील त्यामुळं काय असतो इथं समजा एक मिनिट मॅक्झिमम ब्लेड एफिशियन्सी वी गॉट इट ॲज ए this is what cos square alpha 1 divided by 2 into bracket 1 plus k into b सी तर के जे आहे ते काय आपण CR2 अपॉन CR1 हे जे के जर फ्रिक्शन नसेल आयडियल केसमध्ये काय शकतं के इज इक्वल टू 1 म्हणजे काय असतात त्या केसमध्ये CR2 इज इक्वल टू CR1 म्हणजे तिथं फ्रिक्शन नाही दोन्ही पण रिलेटिव्हसाठी कंपाऊंड काय असतील सेम आयडियल केसमध्ये आणि बीटा ब्लेड अँगल जे आहे किंवा सी ब्लेड कोइफिशियंट किंवा सी किंवा ऑर सी बी ऑर सी ओके शुड बी ऑल्सो इक्वल टू व्हॉट अँग्युलर ब्लेड जर इक्वी अँग्युलर असतील म्हणजे इनलेटचा अँगल टोच आणि आउटलेटचा अँगल टोच तर आपला काय सी म्हणजे काय कॉस बीटा 2 डिवाइड बाय कॉस बीटा 1 जर इक्वी अँग्युलर असतील तर व्हॉट इज दॅट इक्वी अँग्युलर असतील तर काय असणार ते if they are equiangular then it will become again 1 आणि maximum blade efficiency it is expected that they should be equiangular okay and in that case this k पण 1 आणि बीटा पण 1 b पण 1 किंवा c पण 1 तर हिची व्हॅल्यू काय येईल इटा ब्लेड मॅक्झिमम इटा ब्लेड मॅक्झिमम काय येईल आपली cos स्क्वेअर अल्फा 1 divided by 2 into 1 plus 1 into 1 it will become what 2 and in that case lecture under this 2 will get cancelled and in that case here maximum blade efficiency we are getting is equal to cos square alpha 1. So in case of the impulse steam turbine in case of the impulse steam turbine, the maximum blade efficiency is given by equation cos square alpha 1. Okay. Understood? Understood if right? Yes, here. Anybody having problem, please see. Understood? Yes, okay. Shaneshwar, good. Shaneshwar Misal, yes. Only Shaneshwar is understanding, others. Please write, okay, cos square alpha 1. Okay. Now here, I will go to that slide. Okay. Now here from above question it is given that diagram efficiency depends on nozzle angle alpha 1 blade angle ratio blade speed ratio rho blade angles beta 1 and beta 2 blade velocity coefficient k okay if the values of alpha 1 theta are assumed to be constant diagram efficiency depends only on value of blade speed ratio rho in order to determine the optimum value of for maximum diagram efficiency आपण हे केले आणि ऑप्टिमम व्हॅल्यू किती आली ब्लेड स्पीड रेशोची cos अल्फा 1 डिवाइड बाय 2 ओके तर आपण ते सॉल्व करून काय आली आपली 1 प्लस के सी इथे आपण बी ला आपण सी म्हणले कॉन्स्टंट आहे हा काय पुस्तकामध्ये बी म्हणलेलं आहे काय पुस्तकामध्ये सी 1 प्लस के बी किंवा के सी कॉस स्क्वेअर अल्फा डिवाइड बाय 2 and if the blade is symmetrical and friction is absent then beta 1 is equal to beta 2 and k is equal to c is equal to 1 okay then maximum blade efficiency is equal to what cos square alpha 1 and in that case work done per kg of steam per second is equal to v1 cos alpha 1 minus u into bracket 1 plus kc into u then cos square alpha 1 okay then the maximum rate of doing work per ton is equal to 2u square म्हणजे इथे जर आपण cos square alpha 1 ची व्हॅल्यू जर आपण काय केली मॅक्झिमम धरली तर हियर इट विल बिकम 2u स्क्वेअर आणि ब्लेडची व्हॅल्यू जर आपण इथे पुटअप केली कुठली यू आपण तर मॅक्झिमम काय येईल ब्लेड व्हेलॉसिटी रेट ऑफ डुईंग वर्क पर केज ऑफ टीम इज इक्वल टू 2u स्क्वेअर आणि आपण कंपाऊंडिंग आपण वे हॅव सीन ओके तर दिस कम्प्लीट्स आवर थिअरी फॉर दिस युनिट नंबर 2 आणि ह्याला रिॲक्शन टर्बाईन आपले आहे त्यामध्ये काय दोन्हीमध्ये फिक्स्ड ब्लेडमध्ये आणि मुव्हिंग ब्लेडमध्ये दोन्हीमध्ये काय होतो एन्थाल्पी ड्रॉप होतो आणि फक्त इम्पल्स टर्बाईनमध्ये एमसीक्यू मी टाकलेला आहे आयएससीला इम्पल्स टर्बाईनमध्ये फक्त नोझलमध्ये एन्थाल्पी ड्रॉप होतो पुन्हा काय होतं एन्थाल्पी ड्रॉप होत नाही आता रिॲक्शन टर्बाईनचं पण तसंच आहे सेम फॉर्म्युले आहेत आपले वर्क डन पर केज ऑफ टीम u into bracket u into vw1 plus vw2 into okay into newton meter okay work done m into u cw vw1 plus vw2 newton meter per second or watt okay आणि पॉवर डेव्हलप्ड तीच आहे फॉर्म्युला रिॲक्शन टर्बाईन आणि इम्पोर्टर मध्ये काय फरक नाही इफिशियन्सी पण तीच आहे ओके फक्त आता डिग्री ऑफ रिॲक्शन रिॲक्शन टर्बाईनचा काय असतो तर डिग्री ऑफ रिॲक्शन टर्बाईन in reaction turbine is defined as रेशिओ ऑफ आयसेंट्रॉपिक हीट ड्रॉप इन मुव्हिंग ब्लेड टू आयसेंट्रॉपिक हीट ड्रॉप इन एंटायर स्टेजेस. म्हणजे मुव्हिंग ब्लेड आणि फिक्स्ड ब्लेड. एंटायर स्टेज म्हणजे कुठली? मुव्हिंग ब्लेड आणि फिक्स्ड ब्लेड. म्हणजे एन्थाल्पी ड्रॉप इन मुव्हिंग ब्लेड डिवाइड बाय टोटल एन्थाल्पी ड्रॉप. टोटल एन्थाल्पी ड्रॉप म्हणजे मुव्हिंग ब्लेड मधला आणि फिक्स्ड ब्लेड मधला. DH1 एन्थाल्पी ड्रॉप इन फिक्स्ड ब्लेड, DH2 एन्थाल्पी ड्रॉप इन मुव्हिंग ब्लेड. तर DH2 डिवाइड बाय DH1 प्लस DH2 इज नथिंग बट व्हॉट? डिग्री ऑफ रिएक्शन. आणि एक टर्बाईन आहे आपला, एक पार्सन टर्बाईन म्हणून आहे, त्याचं डिग्री ऑफ रिएक्शन इज इक्वल टू 50% किंवा 0.5. आणि त्या टर्बाईनला आपण काय म्हणतोय? एअर पार्सन्स रिएक्शन टर्बाईन. तो पार्सन्स रिएक्शन टर्बाईन इज अ टर्बाईन हुज डिग्री ऑफ रिएक्शन इज 0.5 or 50%. लिहून घ्या कुठं. पार्सन्स रिएक्शन टर्बाईन इज अ स्पेशल केस ऑफ रिएक्शन टर्बाईन फॉर विच डिग्री ऑफ रिएक्शन इज 50%. म्हणजे तिथं मुव्हिंग ब्लेड मध्ये पण तेवढा ड्रॉप होतोय आणि फिक्स्ड ब्लेड मध्ये पण तेवढा ड्रॉप होते. तर त्या टर्बाईनला आपण काय म्हणतोय? पार्सन्स रिएक्शन टर्बाईन, ज्याचं डिग्री ऑफ रिएक्शन काय आहे? 0.5 किंवा 50%. तर डिग्री ऑफ रिएक्शन म्हणजे काय? एन्थाल्पी ड्रॉप इन रेशिओ ऑफ एन्थाल्पी ड्रॉप इन मुव्हिंग ब्लेड डिवाइड बाय एन्थाल्पी ड्रॉप इन टोटल एन्थाल्पी ड्रॉप और एन्थाल्पी ड्रॉप इन स्टेजेस, that is moving blade plus fixed blade. Okay. And Parsons reaction turbine is a special case of the reaction turbine in which the degree of reaction is 50% किंवा 0.5. Okay. Then in that case in here 0.5 त्यामध्ये काय लागते मग? त्यासाठी अँगल जे फिक्स्ड अँगल ब्लेड मुव्हिंग ब्लेड आणि फिक्स ब्लेडचे अँगल सेम असले पाहिजे किंवा मुव्हिंग ब्लेड आणि फिक्स ब्लेड सेम शेपचे असले पाहिजेत, तर त्याला काय म्हणतो आपण? पार्सन्स रिएक्शन टर्बाईन. आणि डिग्री ऑफ रिएक्शन जर 0 असेल तर काय होईल? ड्रॉप इज इक्वल टू 0. देन टर्बाईन इज सिंपल आयसेंट्रॉपिक टर्बाईन. म्हणजे तिथं फक्त काय होईल? 0 म्हणजे तिथं काय एन्थाल्पी ड्रॉप मुव्हिंग ब्लेड मध्ये होत नाही आणि टोटल एन्थाल्पी ड्रॉप हा काय असतो? नोझल फिक्स्ड ब्लेड मध्ये होतो, नोझल मध्ये होतो. त्यामुळे डिग्री ऑफ रिएक्शन ही इम्पल्स टर्बाईनची किती असते? 0. आणि डिग्री ऑफ रिएक्शन इज इक्वल टू 1. द इम्पल्स टर्बाईन इज कॉल्ड एज प्युअर रिएक्शन टर्बाईन. म्हणजे डिग्री ऑफ रिएक्शन जर 0 असेल तर इम्पल्स तो आहे झाला आपला इम्पल्स टर्बाईन. बिकॉज इम्पल्स टर्बाईन मध्ये मुव्हिंग ब्लेड मध्ये पण किंवा पण ड्रॉप 0 होतो, म्हणून इम्पल्स टर्बाईन मध्ये डिग्री ऑफ रिएक्शन 0 आहे. आणि प्युअर रिएक्शन टर्बाईनचा डिग्री ऑफ रिएक्शन काय आहे? प्युअर तर किती आहे? तो 1 आहे. ओके. आणि 0.5 इम्पल्स डिग्री ऑफ रिएक्शन जर 0.5 असेल तर तो टर्बाईन कसला झाला? पार्सन्स रिएक्शन टर्बाईन. अंडरस्टँड? मला आता एक सांगा. डिग्री ऑफ रिएक्शन अनम्यूट होऊन, डिग्री ऑफ रिएक्शन इज 0 दॅट टर्बाईन इज कॉल्ड एज. MCQ ला विचारले जाणारे प्रश्न आहे ते. डिग्री ऑफ रिएक्शन इज 0 then that turbine is called as box. Degree of reaction 0, so that turbine is called as. Anybody message it?
Simple turbine.
It is a simple impulse turbine. Good. So as is impulse and degree of reaction is 0.5 and that turbine is called as 0.5 असेल तर Parsons reaction turbine, not impulse. Parsons reaction turbine. आणि डिग्री ऑफ रिएक्शन प्युअर रिएक्शन टर्बाईनची डिग्री ऑफ रिएक्शन किती असते? प्युअर रिएक्शन टर्बाईन डिग्री ऑफ रिएक्शन 1. ओके. तर डिग्री ऑफ रिएक्शन हे काय? 0 इम्पल्स टर्बाईन, डिग्री ऑफ रिएक्शन प्युअर रिएक्शन टर्बाईनची 1 आणि पार्सन्स रिएक्शन टर्बाईनची डिग्री ऑफ रिएक्शन 0.5 किंवा 50%. आता हीच डेरिवेशन आपल्याला आहे, ते डेरिवेशन आपल्याला आहे फक्त रिएक्शन टर्बाईनची ऑप्टिमम ब्लेड स्पीड रेशो किती असतो? कॉस अल्फा 1. आणि इम्पल्स टर्बाईनचा किती आहे? एनीबडी रिमेंबर केलं असेल तर इथं ऑप्टिमम रो ऑप्ट व्हॅल्यू ती आपल्या रिएक्शन टर्बाईनच्या वरकडून आपल्या डेरिवेशन सिलेबसला नाहीये, तरी पण आपल्या असं माहितीसाठी डिग्री ऑफ ऑप्टिमम व्हॅल्यू ऑफ रो फॉर रिएक्शन टर्बाईन यात किती आहे? कॉस अल्फा 1. आपण जर सोडवत गेलो इक्वेशन याला तर डिग्री ऑफ ह्याला ऑप्टिमम व्हॅल्यू ऑफ रो फॉर ऑप्टिमम व्हॅल्यू ऑफ रो तर किती आहे? कॉस अल्फा 1. आणि इम्पल्स टर्बाईनची किती होती मगाशी डेरिवेशन मध्ये? कॉस अल्फा 1 बाय 2 आणि त्याचा मॅक्झिमम ब्लेड इफिशियन्सीचा फॉर्म्युला आहे 2 कॉस स्क्वेअर अल्फा 1 डिवाइडेड बाय 1 प्लस कॉस स्क्वेअर अल्फा 1. डिग्री ऑफ रिएक्शन काय 2 कॉस स्क्वेअर अल्फा 1 डिवाइड बाय 1 प्लस कॉस स्क्वेअर अल्फा 1. ओके, हे डेरिव्हेशन आहे. रिएक्शन टर्बाईनचं डेरिव्हेशन आपल्याला नाहीये. इम्पल्स टर्बाईनचं डेरिव्हेशन आहे, पण आता आपली एक्झाम एमसीक्यू टाईप असल्यामुळे डेरिव्हेशनला खूप किंमत कमी आहे. पण मी का तुम्हाला डिफाईन केलं डेरिव्हेशन, कारण त्यातल्या टर्म आपल्याला पटकन समजतात. तर आता डिग्री ऑफ रिएक्शन समजलं. आता मॅक्झिमम इफिशियन्सीसाठी ऑप्टिमम व्हॅल्यू ऑफ रो इम्पल्स टर्बाईनची किती आहे कॉस अल्फा 1 डिवाइड बाय 2. रिएक्शन टर्बाईनची किती आहे कॉस अल्फा 1. मॅक्झिमम ब्लेड इफिशियन्सी इम्पल्स टर्बाईनची किती फॉर्म्युला जातो, इट इज बिकम कॉस स्क्वेअर अल्फा 1 आणि रिएक्शन टर्बाईनचा 2 कॉस स्क्वेअर अल्फा 1 डिवाइड बाय 1 प्लस कॉस स्क्वेअर अल्फा 1. हे डेरिव्हेशन तुम्हाला विचारलं जाणार नाही, पण यू शुड नो इट. ओके, आता गव्हर्निंग ऑफ टर्बाईन म्हणजे गव्हर्निंग ऑफ टर्बाईन आपल्याला नाही तरी पण तुम्हाला टर्म मध्ये पुढच्या वेळेस आहे. गव्हर्निंग म्हणजे स्पीड कॉन्स्टंट कसं मेंटेन करायचं, तर त्यामध्ये ते 3 मेथड्स आहेत: थ्रोटल गव्हर्निंग, नोझल गव्हर्निंग आणि बायपास गव्हर्निंग. तर ह्या त्या फ्लो कंट्रोल, स्टीमचा फ्लो कंट्रोल करून आपण स्पीड ऑफ टर्बाईन आपण कंट्रोल करू शकतो. जर टर्बाईनचं स्पीड जर वाढलं तर आपण स्पीड काय करायचं, गव्हर्नरच्या साह्यानं स्पीड कमी करायचं. ओके, स्टीमचा फ्लो कमी करायचा आणि टर्बाईनचं स्पीड कॉन्स्टंट ठेवायचं. आणि जर स्पीड जर त्याचं कमी झालं तर स्टीमचा फ्लो वाढवायचा, जेणेकरून आपल्याला टर्बाईनचं स्पीड वाढेल. तर हे गव्हर्नर आहे सेंट्रिफ्युगल गव्हर्नर. याच्यामध्ये जर गव्हर्नरचं स्पीड जर कमी झालं तर काय होईल, कमी झालं तर हे कमी वेगानं फिरतील हे इथले बॉल्स, आणि बॉल्स कमी वेगानं फिरल्यानंतर ही स्लीव आहे ती कमी वेगानं काय होणार आहे, स्लीव ही पण आहे ती काय होणार आहे कमी वेगानं फिरल्यामुळं. ओके, तर ही स्लीव ही आहे ती खालच्या बाजूला राहते आणि फ्लो त्या केसमध्ये स्टीमचा फ्लो काय होतो, कमी वेगानं आपली स्टीम पडते. जर आपल्याला जर इथं स्पीड वाढायचं तर स्टीमचा फ्लो जर वाढवला तर हे जर आपण खाली घेतलं लिव्हर जर आपलं खाली आलं तर हे गव्हर्नरचं स्पीड तुमचं काय होतं, वाढतं. म्हणजे दिस इज बाय द गव्हर्निंग ऑफ द टर्बाईन. आपल्या सिलेबसला नाही तरी पण आपलं तुम्हाला माहितीसाठी असावं. गव्हर्निंग म्हणजे टू मेंटेन द कॉन्स्टंट स्पीड ऑफ द टर्बाईन, आणि ह्यासाठी थ्रोटल गव्हर्निंग, नोझल गव्हर्निंग, बायपास गव्हर्निंग किंवा ह्या तीनचे कुठलेही कॉम्बिनेशन करून आपण स्पीड मेंटेन करू शकतो टर्बाईनचं कॉन्स्टंट. ओके, तर गव्हर्निंग आपल्या सिलेबसला नाहीये. आणि हे लॉसेस आपल्याला माहित असावे कुठले कुठले लॉसेस होतात स्टीम टर्बाईनमध्ये. तर स्टीम टर्बाईनमध्ये काय, लॉस ऑफ डीम फ्रिक्शनमुळे, स्टीमच्या फ्रिक्शनमुळे स्टीमची एनर्जी लॉस होते. रेग्युलेटिंग वॉल्स असतात, त्या वॉल्समध्ये थोडीफार स्टीमची एनर्जी काय होते, लॉस होते. स्टीम वॉल आपली नीट पॅक आपण व्यवस्थित क्लोज न केल्यामुळं लिकेज होतो, त्या लिकेजमुळे थोडा लॉस होतो. मेकॅनिकल फ्रिक्शन असतं बिअरिंगमध्ये वगैरे, त्यामुळे थोडा लॉस होऊ शकतो. लॉस ऑफ वेटनेस, जर स्टीम जर वेट असेल तर स्टीमची काय होते, लॉस होऊ शकतो एनर्जीचा. देन रेडिएशन, आपली स्टीम हा टर्बाईन हा ची जे पार्ट आहेत ते एक्सपोज टू ॲटमॉस्फिअर, आणि स्टीम टर्बाईन स्टीम ही हॅव्हिंग टेम्परेचर मोर दॅन ॲटमॉस्फिअर टेम्परेचर, त्यामुळं एक्सपोज हीट टू द रेडिएट्स हीट टू द ॲटमॉस्फिअर, इट इज वन काइंड ऑफ लॉस. मग ती जी हीट आहे ती कधी कधी आपण रेडिएट केली जाते, कारण टर्बाईनचे पार्ट्स एक आहेत हॉट असतात, हॉटर दॅन ॲटमॉस्फिअर टेम्परेचर. रेसिड्युअल स्टीम लॉस, कधी कधी स्टीम टर्बाईनमध्येच राहते. ओके, त्यामुळे तिथं रेसिड्युअल व्हेलॉसिटी लॉस ऑफ स्टीम लॉस, लॉसेस इन रेग्युलेटिंग वॉल्स, लॉस ड्यू टू स्टीम फ्रिक्शन, लिकेज, मेकॅनिकल फ्रिक्शन, स्टीम वेट असल्यामुळे थोडा लॉस होतो, रेडिएशनमुळे लॉस होतो. हे स्टीमचे काय आपले लॉस आहेत. ओके, तर हे आपल्या थिरॉटिक थेअरी जे आहे लॉसेस महत्वाचे आहेत, मेन्शन द लॉसेस. तर मग ह्याच्यामध्ये जास्तीत जास्त सगळ्यात महत्वाचा लॉस हा फ्रिक्शनमुळे होतो. ओके, तर हा लॉस मॅक्झिमम लॉस कुठला आहे, फ्रिक्शन. ओके, तर दिस कम्प्लीट्स आवर थेअरी. न्यूमेरिकल नसल्यामुळे आता कम्प्लीट द युनिट नंबर 7. ओके, एनीबडी हॅव्हिंग नाऊ अंडरस्टँड काय मी दिस पीपीटी आय वेदर आय सेंड, पीपीटी मी सेंड केली का? ओके, सो शॅल आय कन्सिडर दॅट युनिट नंबर 7 इट कम्प्लीटेड. पीपीटी सेंड केली मी तुम्हाला. Anybody give